In this problem, we need to graph the rational function f of x equals -6 divided by x squared plus x minus 12. We're going to have to find a whole lot of different things for this function, but before we start, it's always good to make sure nothing simplifies in your function. It doesn't look like it's going to, but it's always good to factor everything that can be factored in the function. So I have f of x equals -6 divided by, my denominator hopefully will factor. It's one of the easy ones. The leading coefficient of the x squared is a 1. So I know I'm just going to have an x and an x. I need two numbers that multiply to a negative. It means I have to have opposite signs in my parentheses. They're going to multiply to -12 and add to +1, so I have to have +4 and -3. Now everything is factored. Does anything reduce? No. So now we're ready to look at, does the graph have y-axis symmetry or origin symmetry? If it has one of these, it makes graphing a whole lot easier. So let's look at the graphs of even functions are symmetric with respect to the y-axis. And for even functions, f of -x equals f of x. So I'm going to have to find f of -x. That means in my function, I'm going to use this version of my function. Wherever I see an x, I'm going to put a -x. So I'm going to have -6 divided by, instead of x squared, I have -x all squared, plus, instead of x, a -x minus 12. So I have -6 divided by -x all squared is +x squared, plus a -x is just -x minus 12. Is this the same as my original function? No, this term here is different. So this does not equal f of x. My function is not even. It doesn't have y-axis symmetry. Now we need to look at origin symmetry. So the graphs of odd functions are symmetric with respect to the origin. And odd functions, f of -x equals -f of x. I've already found f of -x here. All I have to do now is find -f of x. So it's negative, my function, which is -6, all divided by x squared plus x minus 12. So -1 times -6 is +6 over x squared plus x minus 12. Now, is this the same as what we found up here for f of -x? No, they are not equal. So -f of x does not equal f of -x. So my function doesn't have symmetry about the origin. So this function doesn't have any symmetry that will help in the graphing. Going on to the next slide, I now need to find the y-intercept. And how do you find the y-intercept of any function? You set x equal to 0. So I'm going to have to find f of 0. So it's going to equal -6 over 0 squared plus 0, and then finally minus 12. So it's -6 divided by 0 squared plus 0 is 0, so the only thing in the denominator is -12. So I have -6 divided by -12, which when I reduce it gives me +1/2. So my x-intercept is 0, 1/2. Next, we need to find the x-intercepts. And how do you find the x-intercepts of any function? You set y equal to 0, or in this case, you're going to set f of x equal to 0. So I'm going to have 0 equals, I'm going to use this form of the function, negative 6 divided by x squared plus x minus 12. There's several different ways of solving this. I'm just going to divide 0 by 1, turn this into a proportion that I can then cross multiply. 0 times x squared plus x minus 12 is 0, equals 1 times negative 6 is negative 6. Does 0 equal negative 6? Hopefully not. So this is a false statement, so there are no x-intercepts. Next, we need to find any vertical asymptotes. And you find vertical asymptotes using the simplified form of the function. I could use either of them, but the second one is going to be a lot more useful. And to find the vertical asymptotes, you set the denominator equal to 0. So I'm glad we've already factored it. So I have x plus 4 times x minus 3 equals 0. Two things multiplied together equals 0. Using the 0 factor property, you have x plus 4 equals 0 and x minus 3 equals 0. From the first one, subtract 4 from both sides. X equals negative 4. From the second one, add 3 to both sides. You get x equals positive 3. So these are the equations of my vertical asymptotes. And going on to the next slide, we need to find any horizontal asymptote for this function. Horizontal asymptotes depend on the degree of the numerator and the degree of the denominator. So looking at my function, what is the degree of the numerator? Remember, all constant terms have a degree of 0. What is the degree of the denominator? What is the highest exponent on any of my x's in the denominator? It is a 2. So this is a case where the degree of the numerator, excuse my terrible handwriting, is less than the degree of the denominator. And in that case, the horizontal asymptote always has the equation y equals 0. So now the only thing left to do is we need to graph our function, and we might need to plot some additional points. To see if I need any additional points, I'm just going to sketch my two vertical asymptotes where x equals negative 4, and the other vertical asymptote was x equals positive 3. I need to have a point in each of these three regions. The only other point I've found so far is the y-intercept of 0.5. So I'm going to have a point to the left of negative 4 and to the right of positive 3. So let's figure out f of negative 5. So it's going to be in this region here. I'm going to use this form of the function. I think the arithmetic is a little easier. So I have negative 6 over negative 5 plus 4 times negative 5 minus 3. So I get negative 6 divided by negative 5 plus 4 is negative 1 times negative 5 minus 3 is negative 8. So I have negative 6 divided by positive 8, which is going to be negative 3/4. So that's going to give me the point negative 5 and negative 0.75. Because when you graph it, you prefer to graph 0.75 than 3/4. And lastly, I need a point where x is bigger than 3. So f of 4 equals negative 6 over 4 plus 4 times 4 minus 3, which is negative 6 divided by 4 plus 4 is 8 times 4 minus 3 is 1. So it's negative 6/8, which is negative 3/4. So that point is the point 4, negative 0.75. So now I'm ready to graph my function. The first things we need to graph are the asymptotes. Remember, there was a vertical asymptote when x equals negative 4. So I have a vertical dotted line when x equals negative 4. The other vertical asymptote was when x equals 3. We also had a horizontal asymptote of y equals 0, otherwise known as the x-axis. Next, we found the y-intercept that is right here at the point 0, 0.5. And we also found there were no x-intercepts, so the graph does not cross the x-axis. In some cases, graphs can cross their horizontal asymptote, but it doesn't happen in this case. As we've already plotted a point in the center region of the graph, let's work on the graph there first. At vertical asymptotes, we know the graph will either increase without bound or decrease without bound. But in this case, if the graph was going to go down in this region or in this region, it would have to cross the x-axis, and we know it doesn't do that because there are no x-intercepts. Therefore, we know the graph has to start up here. It's going to come down, turn around, and then go back up again. We don't know exactly where it's going to turn around, but we know it doesn't cross the x-axis. So let's graph that region. And there's our graph. We didn't have a point at all in this region, so we calculated one when x equals negative 5. And that was the point negative 5, negative 0.75 right here. Remember, graphs cannot cross the vertical asymptote, and in this case, it doesn't cross the horizontal asymptote, so the only place for our graph to go is down in this region here. So let's sketch that in. And finally, in this region, we calculated one more point. When x was 4, f of x was negative 0.75, which gives me this point. Again, the graph cannot cross the x-axis or the vertical asymptote, so the only place for it to go is in this region. So let's sketch that in. And so there is the graph of this function.